Okay, so let's get started. We are going to be finishing up with classes and separate compilation today, and we're also going to be talking about randomization algorithms. I also have several announcements. So first of all, someone pointed out there was a discrepancy between the intermediate lab deadline for Lab 3 between Canvas and the course site. Canvas was correct. The intermediate part of the lab is due essentially tonight. So tomorrow morning at 8 or 6 a.m. And the reason for that is we gave you a week to do the easier part. Okay? And we're only giving you, in essence, 4 days to do the more complicated part. So we want you to have the easier part of the lab done by the time you go into lab tomorrow, so that tomorrow in lab you're focusing on the complicated portion of the lab. Now I understand some of you have found the first part complicated, and I appreciate that, but all I can say is the second part is probably more complicated. So we need to have you done and moving on to the other part. So just whatever you have by 6 a.m. tomorrow, hand in. Even if it's not complete, you can still get partial credit for the test cases that are working. But it's a hard deadline. We won't take a late submission. If you submit late, you'll get a 0 for that first part of the lab. So submit what you have, and you can get points for the parts of it that are working. Second announcement, we have our first midterm coming up. So the lab portion is on Wednesday, next Wednesday, February 14th. And the in-class portion is on Thursday, February 15th. And it will follow the format of my previous exams, and you can find an example previous exam if you go to Exams and you go to Sample Previous Exams. Then Midterm 1 is a good one to look at. Now, sometimes I get requests for more exams. No. What I find is that students just study the previous exams and don't study the material. One exam is good enough for you to see how I create my exams. You need to study the material, though, because I don't limit myself to what's on the exams. And I just had bad experience with students only studying exams and then saying, oh, well, I just studied the exams. No, you have to study the material. So I give you one exam. Also, you can see one of Dr. Planck's old exams, so that gives you some other sample problems to work with. It covers all the material up through hashing, which we will be covering Thursday and Tuesday. Now, you won't have had an opportunity to program with either classes or with hashing, so as far as the programming portion, the coding questions, they will be up through 2D vectors, what you have been working with in Lab 3. But as far as what's on the paper version, that's everything up through Tuesday. And the in-lab portion, the coding questions are done with Code Assessor. I'm currently thinking there will be 2 such questions. Unlike CS 102, we do look at your code and give you partial credit if you haven't been able to complete it. I know that some of you may not be able to complete the coding questions. You get the full class or full lab period of 2 hours. It helps in terms of you're being able to move around the code, being able to write it clearly, typing it instead of handwriting it, so it's easier for me to review. And you have a lot of time, 2 hours, as opposed to trying to cram everything into an hour, 15 minutes in class. I will go over a little bit more of things probably Thursday, but are there any preliminary questions about the exam? Okay. Also, for the coding portion, you will be allowed a 1-page cheat sheet front and back that you can put anything on, but not for the in-class portion. The in-class portion on Thursday, you will not be allowed to have any notes. But for the coding portion, you will be allowed to have a one-page cheat sheet front and back. And I'll tell you a little bit more on Thursday what I would put on that cheat sheet. It's usually not what I find on cheat sheets. Okay, so those are the announcements. Oh, one other thing. We are getting a lot of posts to Piazza with code, which is fine. But there's usually a couple important things missing with those posts that we really need in order to be able to help you. Okay? One is we need the input case on which it's failing. And the second thing we need is comments. Okay? Tell us what you think the code is doing. Because what you think the code is doing and what you have written are often two completely different things. Okay? And so I'm looking at sometimes the code and there's no comments or very sparse comments, and I can't be sure what you think you're doing. Okay? So it'd be really helpful if you commented it and said, this is what I think it's doing. Okay? Like if you're saying the pad function, you might say, first I think that I am moving the image to the right. And then I'm padding the top. And then I think I'm moving the image down, okay, which you shouldn't be doing. You should be moving it in one move rather than two moves. But I'm just saying, tell me what the steps are that you think you are doing in that function to accomplish the task. Because at least if you say what you think you're doing, and then we look at it, we may be able to say, okay, this is not what you're doing, and this is how we can move you toward doing that, okay? So those two things have been missing from a lot of the posts that have been sent to the instructors, and it would really help us if you do those two things. Okay, because the programs are getting complicated. We can't anymore just look at it in 2 minutes and know what's going on. Okay, it takes us a while to figure out what's going on, and you can really help us with this information. Okay, so let's continue with what we started at the end of last period, which was separate compilation. Okay, you may remember that, in fact, you know what? I am going to have you quickly do this exercise. It is from my midterm exam the last time. Okay, so I want you to try to do question 2 here. Just take a few minutes and try to do question 2, because it's good review for what we talked about at the end of the period last time. If you can't read this, go to my exams website and click on midterm 1. Okay, I'm going to give you about 5 minutes to do this because it shouldn't take that long. Okay, how many of you need some more time? Okay, in that case, I will go over the answers. So the first question says, so we have a class named ballot. We're using it in a program named vote.cpp. So the first question says, in what file should the class declaration for ballot be placed? Well, we place class declarations in header files. And we give the header file the same name as the name of the class. So the name of the class is ballot. And what is the extension for a header file? .h. So it should go in ballot.h. Header files have a .h extension. Now, then I said, in what file should the method definitions for ballot be placed? So this is where the function bodies go. Well, same thing. You name the file ballot, the same name as the class, but now the method definitions go in the CPP file because that's got executable CPP code. And you would include ballot.h in ballot.cpp. And if you remember, the include command simply copies the contents of the .h file into the .cpp file. It literally the preprocessor literally copies, replaces ballot.h or the include ballot.h with the contents of ballot.h. So at that point, ballot.h is actually embedded in ballot.cpp. So now a single G++ statement. So we use the -o flag to put it in an executable named vote. The -o flag says put it in the file named vote. And there are two .cpp files. We have to compile vote.cpp and ballot.cpp. We never put a .h file. We never try to compile a .h file because it's already been physically included in vote.cpp and ballot.cpp by the #include statement. So there's absolutely no reason to put .h files on the to try to compile them. Yes?
Does the order matter?
Nope. Turns out the order does not matter. Usually I like to put the main program first, but the order's immaterial. It's a good question. Other questions? I think I saw a hand in the back. No? Okay. And then the last one was, I'm not answering D. I have space, so I'm answering E right now, just so you were clear on this. So E, I want to execute vote from the command line. So to do that, I first have to tell the shell where to find the file. So if I'm currently in that directory, which I usually am, / says to look in the current directory. And then the name of the executable is vote. The indirect sign for the Unix shell is less than. So I am redirecting standard in from ballots.txt. And I'm redirecting the output. The way you do that is with the greater than sign to results.txt. And again, it doesn't matter whether you switch these. You could have actually put the greater than into results.txt first. So if I had instead put that first, it doesn't matter. Okay? What Unix is looking at is the symbol. When it sees the symbol, it automatically says the next file is going to do whatever that symbol says. Now, does someone know how we would redirect error output? If we wanted error output redirected somewhere. Okay? It is a double greater than. So if we wanted the error output sent to another file, it is a double greater than sign. So remember that CERR actually is what you typically use to print to what we call standard error. And normally, standard error prints to the console just like standard out. But sometimes you wish to redirect the two streams, which is what Dr. Planck does in his grade scripts. You get a standard out file and a standard error file. And that's what he's doing. He's redirecting the two streams to different files. And that's how he's doing it. A single greater than for standard out, a double greater than for his error output. Okay, and if you're using printf, then you have to use fprintf to get to standard error, and you say standard error, and then you give the format string, and then you give the variables if you're using, you can't, printf writes to standard out. If you want to use a printf statement to write to standard error, you use fprintf, which stands for file printf, and then you gave it the device that you're printing to, which is standard error. So C error prints to standard error, fprintf, standard error prints to standard error. Okay? Normally standard error prints on the console, but you can separate the standard output and the standard error streams. Okay? So do we have questions about this? Yes?
Does spacing matter?
It shouldn't. I always put spaces between things, but I don't think so. I think well, to be safe, you should always put white space between these things, just because, for a fact, white space is a delimiter for the Unix shell. So I have to admit, I never tried it without spaces, so I'm not sure. Other questions? Okay. So now we're going to give you the answer to D, which is separate compilation. So when we compile something using G++, if we say G++-O vote.cpp, ballot.cpp, we end up recompiling both vote.cpp and ballot.cpp. But let's say that we only had fixed a bug in ballot.cpp. Recompiling vote.cpp is a waste of time because we haven't changed that file. And in large programs, like if you're working at Amazon where a program might consist of 1,000 different files, it really is a waste of time to change one file and then compile 1,000 files when in fact only one file has changed. So for project management purposes, we can separately compile each file. And the way we do that is with the -C flag. So if we say G++-C, then that compiles the file into what we call a .o file. So that compiles, the -C flag compiles the .cpp file into a .o file. Okay, we call the .o file an object file. Okay, it is not executable. If you tried to execute it, it would not execute, and that is because it has not yet been linked. Remember, there's two steps now to compiling. There's a compile step and a link step where we resolve undefined functions. So this is now, the -C says only perform the first step, which is the compile step, and hold off on the link step. So if we were going to do separate compilation, we would separately compile these. And then we invoke the linker, again with -O, except now rather than giving it the .cpp files, we give it the .o files. And that when we give it just .o files, that tells G++ to only execute the linker. Okay, so this executes the link step, or executes the linker. So with separate compilation, it becomes 3 statements. Okay, G++-C vote.cpp, G++-C ballot.cpp, then G++-O using the .o versions, the object files. And that creates what we call an executable. Okay, so vote, we call that an executable file. So you'll often hear people refer to executables or to object files. They're different. Object files are .o files. They cannot be executed. They are in machine language, but they still require that link step we talked about last time where you resolve function references. Now, if I modified ballot.cpp, but I did not modify vote.cpp, I would only have to execute those two commands. I wouldn't execute the command to compile vote.cpp because its .o file is up to date. I would simply give its pre-existing .o file to G++. Same thing, if I had 1,000 files and I changed one, it would still only be a 2-line recompilation if I changed one file. I would recompile the one file that changed. I would run this link step right here, except now I would list 1,000.o files. Now that's pretty tedious. Okay, typing out 1,000.o files, rather long. One thing you could do is you could put that entire statement into a file and copy and paste it. But there are what we call project management tools that have been developed, and one of them is Makefiles, which is something that you saw in today's readings. So today, I believe it was in chapter 24. There were Makefiles. So a Makefile is essentially a recipe or a set of rules for compiling and linking an executable. And here's an example of one. This is compiling for a Windows executable. So the final executable is myprog.exe, and then after it, so the rule is the name of the executable or the name of the file that we're creating. Then you have the files that it depends on. So in this case, it depends on, it's made from main.o and 3instfuncs.o. Then on a separate line with a tab, and this is important, now you're not going to have to create Makefiles in this course. We're just going to introduce you to them, but it's helpful to get to know what they are. So then a tab, and then the instructions for creating that file. In this case, it's G++, main.o, 3functions.o, and again you can see order doesn't matter because the -o here is at the end of the compile statement. And then since this is separate compilation, we have separate rules for creating the two .o files. So you can see that main.o depends on 3. Actually, it doesn't. This is bad. This should not have been in here. It really only depends on main.cpp and 3functions.h. And then when you compile it, you can see we use the -c flag. -w stands for print all warnings. So when you see -w, it's not wall, even though it looks like that. -W followed by ALL says print all warning messages, mean be really verbose with the warning messages. And then the -c main.cpp, and that creates main.o. Same thing for 3functions.o. It depends on 3instfuncs.cp and 3instfuncs.h. The rule for compiling it is the G++-C. If any of the files on which the so-called target depends changes, then the make command will automatically re-execute the statement to recreate that file. So if I change 3instfuncs.cpp, then automatically make detects that it needs to recompile the .o file, and because then the .o file will change, it must then also redo the link step. If I change the .h file, it would notice that both .o files depended on the .h, so it would recompile both of them, and then it would redo the link step. Okay? So you prepare this file with rules, and then this clean is another command, and it depends on nothing. And when you execute it, it removes all the .o and the .exe. If you're wondering what that star is, the star is called a wildcard character. So the star is a wildcard character that matches anything before a .o. So in effect, it's saying match anything with a .o extension. So we call the targets commands to make. So you can then run, you typically put these commands in a file called makefile with a lowercase m. And then to run the commands in the makefile, you can first of all execute any one of them by giving the target. So if I say make clean, it specifically executes the rule for the clean command. Or if I say make main.o, it specifically makes or runs the instructions associated with main.o. If I just type make without any arguments, so no command line arguments, it assumes that I want to execute the top command, which is in this case is myprog.exe. And if, as we said, some of the things that myprog.exe depends on have changed, it will go out and look at the rules for creating those files and first execute them. So it always executes things in the proper order. Okay, so the make command can be very helpful, and Dr. Plank, I think starting with lab 3 or 4, provides make commands. We, however, do want you to learn how to do separate compilation because it will be on tests. Okay, and eventually you'll have to write your own make files. But that's how make works. Okay, so in general, make has a target, so that's the file being created, a set of what are called prerequisites. So these are the things or the files that it depends on already being up to date, and then one or more commands, and here always a tab before the command, one or more commands to make it with no blank lines. A blank line is the delimiter. When you have a blank line, that signifies the end of the rule for that target. Okay, and you'll notice a common error is to use spaces instead of a single tab character. Again, we will not require you to create make files in this course, but I expect you to know how they operate. Okay? And effectively what's happening is you can think of the makefile as establishing what we call dependencies. So it might be like a.h is used by a.cpp and maybe main.cpp, okay, which those create then actually want to say, don't want to quite say it this way. So it's actually a.h and a.cpp make up a.o, a.h and main.cpp make up main.o, and then these two make up main, or in the case of their things, main.exe. So when something changes, like say a.cpp, it simply follows these dependencies. It says, oh, let's follow the arrow. Okay, a.o depends on a.cpp, so that's one thing we have to modify. Then main.exe depends on a.o, and we need to therefore also modify main.exe. So this is called a graph that Makefile is creating. It's something you'll learn about in 302. It uses something called topological ordering or topological sort to determine the correct order in which to execute the targets in order to make sure that everything compiles properly. Okay, so questions about makefiles. Okay, once again, makefiles were established to help us manage large projects. And they specifically handle separate compilation. Yes?
So, I know you marked out what they had written. What they had included made it incorrect, the refunds.cpp.
Mm-hmm.
So, was that not included was that already included in the main include directive?
No. So the reason that this shouldn't be there because main.cpp in no way, when you compile it, it in no way needs to know about 3insfunc.cpp. It is, when you get to the link step, it will be linked with it. But it's not include, you don't include a CPP file in another CPP file. You only include .h files. Okay, separate compilation says that they are completely separate and in fact ignorant of one another until you get to the link step. So it just literally shouldn't have been there because main.cpp for the compile step in no way depends on 3insfunc.cpp. Now it does include 3insfunc.h, so it does depend on the .h. But it definitely does not include 3insfunc.cpp. Do not include .cpp files. Okay? Only include .h files. Okay, we good with that? Okay. I'm not going to do it, but a good exercise would be to go back and try to do D after class today because I also have all the solutions, so you can look, see what the solution is. It's there, but I need to move on right now. Okay, so, whoops, but you'll need to see my schedule. So we need to finish up classes. And we need to talk about constructors. And we need to talk about a variable called this. Okay, so constructors you learned about in 102. Constructors are used to initialize a new object. So constructors are used to initialize a new object. So they're called whenever you create a new object. And they are always called. Every time you declare a variable like string x, there's actually a constructor called for x. In this case, it's called the zero argument constructor. Does anyone remember from CS 102 or from reading the textbook, what are the two characteristics of constructors that make them differ from normal methods? First of all, I guess if you just looked at the name of a constructor, how would you recognize that it was a constructor? Okay, it has the same name. So two things. First of all, I heard both. Has the same name as the class. So that's the way. And then I heard the second thing. What's the other distinguishing characteristic of a constructor?
No return.
No return type. Okay, because the object's already been created, all you are doing is initializing some variables. Now, as the book says, you can have multiple constructors. So, for example, you might have ballot with no arguments, and you might have another one with ballot, say, string name for the candidate name. You might have yet a third one that might be ballot, say string, this time I'll abbreviate, candidate name, maybe int num votes. And when you declare a variable, the compiler determines which constructor to call based on the number of arguments you provide to the constructor and the types of the arguments. In this case, the number of arguments by themselves determines which constructor gets called. But let's say that I had instead, for some reason, just made this third constructor also have a single argument. In that case, the number of arguments by itself doesn't determine which constructor gets called. The compiler would have to look at the types of the arguments you are passing. Are you passing an int or are you passing a string to determine which constructor gets called? So you can have multiple constructors associated with a class. If you provide no constructors, then you get the default zero argument constructor. So if you provide no constructors, then C++ creates a zero argument constructor that does nothing. So it doesn't initialize anything. Effectively, it's an empty function body. Many students get confused and think that if they don't provide a zero argument constructor, that one will magically be provided for them. So for example, they will define two constructors like this for ballot. But only two, and then they will try to declare a variable like that, and they get an error message from the compiler. The compiler says there is no matching constructor. And I get questions saying, but there's a zero argument constructor. No, there's not. Once you provided your own set of constructors, C++ no longer gave you a default constructor. It's only if you provide no constructors. So only if you provide no constructors do you get a default zero argument constructor. If you provide your own constructors, you won't get one. So if you've provided constructors and you want that variable declaration to work, you will have to provide your own explicit zero argument constructor. Are we clear on that point? Because this is a common pitfall. Okay. Now, another important thing to emphasize is the best practice for initializing variables. Okay? Actually, let's go and look at the book's example. So, initialization and constructors. Make sure that this is okay. So, yes. And what I'd really like to do is get into presentation mode. Don't want to adopt it. How do I get to presentation mode? Nope, not that way. Just a moment. There we go, presentation mode. And let's make it a little smaller so it fits. Okay, so you have here shop item, which is a constructor, is highlighted in yellow. And then you can see that it's a zero argument constructor, and it is initializing name to be equal to no name, and it's initializing price to be equal to -1. So that's what a constructor does. It initializes your variables to default values. Because remember, you can't assume that stuff gets initialized to 0 if it's an int. You can't assume that a string gets initialized to an empty string. You have to do these things explicitly, generally. However, this is not the best way to go about initializing objects like strings. This turns out to be inefficient to use these types of assignment statements. Instead, 2 sections later, the textbook talks about initialization lists. Okay, and it shows 2 different examples. Here's the example where we just do a straight assignment in the body. Here is an example where we're using an initialization list. An initialization list, you'll note, has a colon, then variable names, and then in parentheses, the value. It doesn't matter what order you put them in. It turns out it initializes them in the order that you declared them. So even if I said field 2 first and then field 1, it would initialize field 1 first because it appeared first in your declarations. And you can see it's a comma-separated list, and you can see it goes before the curly braces. If you are initializing primitive types, it doesn't matter whether or not you use initialization lists. So if you are initializing primitive types, it does not matter if you use initialization lists. The reason is C++ generally doesn't bother to initialize anyhow, so the assignment statement's not going to waste any effort. However, if you're initializing object types like strings or vectors, it makes a huge difference. Okay, so here we're only initializing ints. Let's see if they actually do initialize a string or not. Okay, here they do. They initialize a vector. So here's the issue with objects. If you use this one on the left right here, the first thing that happens is because there's no initialization list, it gets initialized anyhow. Remember, you always end up calling a constructor for a class. So and the other guarantee is that when you enter the body of the constructor, all class variables have been initialized. Okay, when you enter the body of a constructor, all class variables have been initialized, or all class variables have had a constructor called to initialize them. So when you didn't give an initial value for the vector on the left, right here, there is no initialization list, it called the zero argument constructor for the vector. So first of all, we've already called, over here, we called the zero arg constructor. And it does some things. Then, when we get down here, we call resize. That executes 2 different functions. Over here, only one thing happens. It calls the one argument constructor, and it takes care of everything. So instead of two calls, which happened on the left, there's only one call when you use an initialization list. So for objects, initialization lists are always more efficient. They basically execute half as many statements. Okay, because of this fact right here. Even if you don't provide an initialization list, C++ will initialize those variables. Okay, by calling whatever argument constructor is appropriate. And then it will also do any further initialization down there, which is inefficient. So the moral of the story is that you always should use initialization lists for initializing class variables. Okay, important enough for me to write it down. Okay, you should always use initialization lists to initialize class variables. If you don't, you are wrecking the efficiency of your program. It's not going to change the correctness, but it will decrease the efficiency because you'll end up effectively initializing that variable twice. So if you do not use an initialization list, you will effectively initialize a variable twice. Whereas if you use an initialization list, you will initialize it once. If I ask you this question on an exam, that's the answer you should give me. You should use an initialization list because it initializes a class variable only once. If you do not use an initialization list, it initializes the variable twice. Okay, and I am fond, every first midterm always has a few questions on it about the right way to do something that has to do with efficiency. Now, I'm not guaranteeing this will be on the exam, but certainly telling you what the right answer is if I put it on the exam. So questions about that? Yes?
If you have like a lot of class variables, you can obviously just, I guess, go to
You can go to a new line. Yep, it's no problem. Just comma separated list. You can use as many lines as you want. And just then after it, you put the left curly brace. So C++ is down with that. Other questions? Yes?
If you want somebody else primitive types, does it matter still?
It doesn't really matter if you have only primitive types, but good form is to use initialization lists actually for everything. If you're going to do it for class variables, you might as well do it for your other variables as well. Okay, but I'm not going to bust your chops for not doing it because it doesn't have an impact on efficiency, or should not. Okay. Other questions? Yes.
What does the zero argument constructor do for you, since there's no elements in that?
So, okay, so the question is, what does the zero argument constructor do for you? You can initialize variables then to whatever you want. So here I decided to initialize the variables to 100 and 200.
Yeah.
Or often I might initialize a sum variable to 0. So if you don't provide your own zero argument constructor, the default zero argument constructor will not do that for you. Okay? It literally does nothing. Okay? So generally, you do want to provide your own zero argument constructor because usually you want to at least initialize your numeric variables to 0 or to something because the C++ compiler is not guaranteed to set them to 0.
What I'm saying is for the second case.
Okay, over here?
No.
Oh.
Go down.
Go down.
Yeah, here since there are no elements in the vector, like integer vector, so what are you initializing?
Well, this is kind of a hokey example. This is okay. Good question. In practice, probably you would not set the resize to 2. Okay, unless it's a game. Let's say it was a game, and for some reason you knew there were 2 elements in the vector. Then maybe it is. Let's say it was tic-tac-toe and it was a 2D vector. You would probably set the vector to a 3 by 3, right? Always. So maybe if it's a game with a fixed size for the game board, you might end up doing it there. Okay, that'd be an example. Other questions? Okay, want to move on. I know there's a bunch to cover today. We got essentially 3 more things. This, HTML, which isn't too bad, and randomization. So there is something called the this implicit parameter. So this is what we call a pointer that is implicitly passed to every constructor and every member function. Not just constructors, but every member function. And this can be used to refer to any object's members. And it's useful when you decide to give the same name to a parameter as you give to an instance variable. So here we have given the parameter the same name as the instance variable. So if we simply wrote side length equals side length, it would assume that it was simply assigning this value back to itself rather than to the instance variable. So the this pointer allows us to unambiguously say that we actually mean that we are referencing the instance variable. So you see it's this and then an arrow. We'll talk about this arrow when we get to pointers, but for the time being, if you use this, you don't use a dot like you have with the other objects. You use an arrow to reference the instance variables. Now, the only time when this is really helpful is when you have named the instance variables the same as a local variable or a parameter. In general, that's a bad idea, but it can happen. So this unambiguously distinguishes an instance variable from a parameter. And it is implicitly declared with every constructor and every method. You do not declare it. Okay, but it is implicitly declared for you and is available for you to use, and essentially is a pointer to that object. Okay, you probably won't find a real need to use this in this class, but you should be aware of it because you will see it in code. And that is what is happening. Questions about this? Okay. Yes?
So why do we bother ourselves to give the same name to like the private variable and the public?
So the question is why bother? And the reason is in really large projects, sometimes when people are maintaining your code, they may not be aware of all the variables that are in the that are member variables. And so they may inadvertently declare a variable locally that has the same name. So it's more for maintenance purposes in large programs, realizing that someone else may eventually maintain your code and not be as intimately familiar with it as you. So some companies, just as a matter of style, will force you to always preface an instance variable with this in order to ensure that when the code is maintained, that you never run into any ambiguity. Okay, so really it comes down to that. It's large projects, it's easy for someone maintaining your code to introduce a new local variable, not realizing it has the same name. You might think, well, why don't they just look at the variable list? Well, when Amazon's website crashes at 1 a.m. and the boss is over there saying, chop, chop, get it up now, because we're losing, $5 million every second you don't get it back up, you're not going up to look at the instance variable list to see whether you're duplicating something or not, right? So in fact, that's why companies like Amazon probably force this so that the maintainability is, it happens. Because you do, believe me, you get emergency coding under pressure where you don't have the luxury of trying to figure out everything that's going on. Okay, other questions? Okay, so I want to show you then an idiom that Dr. Planck is using in creating his rows. Remember, going back now to his roster example, he is creating this table, and he has a certain number of columns per row. And you have the same issue in Lab 3. Dr. Planck has told you that your PGMWrite function should write out how many pixels per row? 20. So you have the same issue. And you can do it many ways, but I just did want to emphasize one of the common ways that you do it, because it is a common idiom. And here it is. So he is now actually breaking his names into rows based on the column size. So he wants to, there are this many columns. And ignore for a moment the table tags. We'll get to that in a moment. Here's the idiom though. It's the mod function. So he is counting I. He's simply going from 0 to the size of the names. But let's say the columns, there's 6 columns per row. That means when I is equal to 6, when I is equal to 12, when I is equal to 18, when I is equal to 24, so on and so forth, you need a column break. And a common way to do that is to use the mod operator. Now you could use a column counter. You could simply have a second variable counting, and when it reaches the number of columns, you could reset that column variable to 0. That's fine too. You couldn't reset I to 0. Why? Let's say that I got up to the number of columns and you reset I to 0. What would happen? What?
You will repeat this row again.
You will repeat the row again, which is correct. And how often will you repeat that row again? Forever. Because if you keep resetting I to 0, when you reach the number of columns, I doubt that I is ever going to become equal to names.size. If name.size is 18 and columns is 6, you obviously should never reset I to 0 because you'll print that first row infinitely. You'll be in an infinite loop. So here's a good way to tackle it. It uses the mod operator. So if you mod I, you can see that every time I reaches a column boundary, if you mod it with the number of columns, the remainder will be 0. So effectively what he's saying is if I've reached a column boundary, I need to start a new row, which you do with the tr tag. Similarly, you need to know when you have reached the end of a row, because in HTML, you denote the end of the row with this /tr, which means end the table row. And that occurs when I is equal to 5, 11, 17, or in other words, when I is equal to columns effect -1. So there, again, we do mod, but now it's I mod columns is equal to columns -1 because we put the ending tag right as we reach the end of the column. So this mod operator is a common technique used when you need to have a certain number of columns per row. Okay. And as you can see, I mod the number of columns indicates you're beginning a new row. I mod columns minus 1 indicates you are ending a row. Okay? So those two things are useful for you to learn, and it would be useful perhaps for you to use in Lab 3, although if you've gotten it to work through some other mechanism, that's fine. I'm not asking you to change it. I'm just asking that you be aware of this idiom. Okay, and finally, HTML uses tags to interpret the data. So you put L tags are in these less than, greater than, and table starts a table, and then to end something, you put the same tag but with a slash in front of it. To start a new row is TR. To start a new column is TD. I don't know why they called it TD. TR stands for table row. TD probably stands for table data, but TC for table column probably would have been more informative. So you output these tags along with your data, and when the browser is asked to display a page, an HTML page, it interprets these tags in order to draw things. So for example, right here, this is a table with one row and one column. The final thing, and then we have a couple representatives from Fast Enterprises to talk to you about co-op and intern opportunities. I did not have time today to go over the in-class exercises. So there is one today, and you should look at it. So it involves two relatively simple challenge activities. It took me like 2 minutes to do them. It will take you probably more like 10, but it will only take about 10. So there is 2 challenge activities today in, I believe, 6.6 with initialization, or maybe it's 6.7. Let's see what it is. Okay, it looks like it's 16.6 and 16.9. So one deals with constructor overloading, one deals with the this pointer. Only 2 challenge activities, should take you no more than 10 minutes, so make sure you do them. Now I would like to, we will go over the randomization algorithms at the start of class on Thursday. I'd like to introduce 2 representatives from Fast Enterprises, Alice Hudson.
Francisco Alatorre.
They will take you to the finish of class today.
Hey guys, my name is Alana Hudson, and I am a recruiter with Fast Enterprises.
I'm Francisco Alatorre, and I'm a implementation consultant with Fast Enterprise.
Okay. And I've been with Fast